Right. So today, I just want to get the general public, clients and kids and possible students to know our course structure or our course outline. So our course outline is like this. We want our students to understand fully from basic up to very complex systems, how to to handle or how to install such systems, depending on the size and complexity, interaction with various technologies and so forth. So it defines what a solar system is, gives an introduction to solar systems. What are they and what do they do? And it gives introduction to storage components. What are they? What do they do? Inverters, charge controllers, and then the source characteristics, which is the sun, relationship of the sun and earth, and irradiance, what affects irradiance and what to do, commissioning and handover of solar systems, maintenance of solar systems, and a little bit of load characteristics that tends to affect the source, which is the solar system, because without the load, then the solar system becomes unnecessary. So the course outline touches a little bit on the load characteristics, dynamics of the load or statics. Is it a static load or is it a dynamic load, and how does it affect the solar system? And why would one want to know about the load characteristics? And then finally, but not least, of course, we touch on financing and the economics of solar systems as compared to conventional power. We want students to be able to explain to clients, if they are asked by a client, is it of financial benefit? What is the return in terms of installing a solar system compared to conventional grid power, and also in terms of reliability, stability, dependability of the energy supply. Right. So the introduction part of radiation physics. In this introductory part, we will talk about the origin of the energy that we want to convert into electrical energy, which is light energy from the sun. It is the light energy that we want to harvest and convert to electrical energy. Now, as the radiation traverses across the atmosphere, it gets deflected, reflected, and so a lot of things happens. And that leads us to define two terms, diffuse and beam radiation, and what percentage is diffuse radiation, what percentage is beam radiation, and how does the location of the solar system affects the amount of power that is collected from the sun, or that is converted to electrical. How does orientation affect the tilt, for example, and what should be the optimal tilt of the solar converters, which are solar panels or solar geysers in this case. So our students will be able to understand all that in terms of understanding what is the angle of incidence and what are the parameters that affect the angle of incidence, and how do we counter the declination of the sun relating to the location in question. How do we make sure that we optimize by trying to get close to standard test conditions of the solar photovoltaic modules, because all solar photovoltaic modules are tested at standard test conditions. What are standard test conditions? These our students will be able to answer, and will be able to understand the nameplate of the solar panel and what each entry there means. What is A mass ratio, what is VOC, what is the IOC, what is the IM, and you know, a lot of things that are written at the back of the solar panel. What does 1000 watts per square meter written at every panel means, you know, which is actually the amount of power that is received per square meter of the Earth's surface. So what efficiency, how does efficiency help us to design and size a solar photovoltaic module in terms of its size, physical size, and what to choose between monocrystalline and polycrystalline photovoltaic modules, and what makes one choose mono or poly, under what circumstances. Our students will be able to answer and design systems accordingly. Then the second part talks about the conversion center, the first conversion center, which is light to electrical, and this happens at the solar photovoltaic module place or point. So our students will understand what is a solar photovoltaic module, what is a solar cell, what is the characteristic of a solar cell, how does it behave when illuminated by light, and what amount of light causes the flow of electrons, or rather the movement of electrons from the valence band to the conduction band, where we actually say now current is ready to circulate if the path is complete. So we will touch on the solar cell and understand the characteristics of a solar cell, and this is where we now touch off for the differences between monocrystalline and polycrystalline solar cells, and what is the advantage of each, what is the disadvantage of each, how does temperature affects the performance of the solar cells, how does the shading of one cell affect the other if they are connected in series or if they are connected in parallel. So we'll also touch on connection configurations. How do you come up with a 330 watt solar module which is made up of solar cells? So we'll touch on that so that our students, when designing solar systems, they sorry for that disturbance, but when our students are designing the solar system, they take that into consideration and make sure that they come up with a system that is reliable. How does soiling affects the performance of a solar cell or a solar module at large? Soiling is the effect of dust particles settling on the surface of the solar module. Is it supposed to be cleaned? How? What are the recommended methods of cleaning up the solar modules? Right. So that is what we'll talk about, and a bit more. Here I'm just giving an overview of what we will be talking about. So that is on solar modules. So this is the active power converter or energy converter. From basics, we know that energy cannot be created or destroyed, but it can be converted from one form to another. So here we have already converted energy from the sun to electrical DC, right? The next stage is the brains that determine charging rate, conversion from DC to AC, which is the inverter stage. Our students will be able to size the appropriate inverter applicable for a certain type of load or appliances. Here we will then deal with the different types of loads, whether the load is static or whether the load is dynamic, and how does it affect our inverter, and to counter that effect, what should be done in terms of sizing the inverter. What size is suitable for what type of load and amount, the power demand from the inverter, the energy demand from the inverter. All those we will discuss about them, the various types of inverters, off-grid, grid-tie inverters. We'll talk about the differences between those inverters that can synchronize with the grid or another source of power and run together with that system at the same speed. Those inverters that cannot, which are called off-grid inverters. We will talk about combining various inverters, how to make the size big, how to choose, how to select the inverter in terms of its incorporated charge controller capabilities, its power factor, its DC input and from the battery, and DC input from the solar panels. Does it take a lot of current from the panels and less voltage, or it takes a high voltage and less current? And what are the differences and advantages of each? How do you choose whether you are choosing an inverter which takes a lot of current against an inverter which takes a lot of voltage? which loosely are called high voltage inverters. Which one is better than the other, and when you choose one, what does it mean to cabling sizing, for example. So how to set parameters in the inverter, how to set priorities in the inverter. So all that will be discussed in this course that we are doing. We then we've talked about an inverter that has got a charge controller. We'll also talk about outside charge controllers and types of charge controllers, PWM, and those that can track the sun or the maximum power point, which are called MPPT incorporated charge controllers. We will talk about these and see, can we put them, how many can we put, and what are the parameters to check when we put possibly 2 or 3 charge controllers on one system or on one battery. Then obviously, because we want our solar system to be reliable, and we know that the sun is going to appear during the day and then sets around 6, rise around 6, sets around 6. So what will happen during the night? This is where we now introduce the storage bit of a solar system. And in this case, our concentration is mainly on batteries. We'll talk about the difference, or rather the different types of batteries. We'll talk about lead acid batteries, gel, AGM, flooded. What is the advantage of each against the other? How to select, what tells you, in this case I'm supposed to use this kind of battery. Our students will be able to do that after completion of the course. Lithium versus lead acid batteries. What is the advantage of each in terms of depth of discharge, in terms of discharge current, maximum discharge current that you can get from the two different types, in terms of lifespan, in terms of cost. We'll discuss about those, and then we'll run a financial analysis using financial method to test if the proposed system is worth the investment. After how much time will the person start to enjoy the investment? Payback period, profitability index, IRR, internal rate of return. We will calculate all those just to give our students an understanding of what to consider when we are designing solar systems. We'll talk about maintenance. What is the maintenance that is expected on solar systems, on solar panels, on inverters, on batteries? What is the kind of maintenance that is expected? And what is expected on commissioning of the system? Handover, takeover. What is supposed to be told the client so that the system is monitored in a healthy manner? What is the significance of understanding the irradiance that we talked about versus energy management. What does it mean, for example, to the client? What should it mean to be a cloudy day? What does it mean to the energy harvest versus energy management? What should be the behavior of the client under such circumstances? So, in general, this is our course outline and what we're going to train, or what we train our students to know. And I would like to thank you. Send your kids, calm yourselves. We can handle any level. We can handle any level that wants to understand more about solar systems and electrical networks in general. We didn't talk about electrical networks, but we will briefly touch, because we've got systems that then integrate to the existing electrical network. So under such circumstances, we will also talk about safety. When dealing with the electricity, there is supposed to be safety. Safety is a priority, because you can't see electricity flowing with a naked eye. You can't. You have to have methods of detecting, methods of isolating, methods of making the operations, maintenance done in a safe manner without any risks. We have to know about discharging circuits. You have to know about all that. So our students will be able to understand that before they can actually carry out the job. So with that, I will leave it here for the students to come. When they come, then we'll give them a detailed training program that we are following. Thank you very much for watching, and hope to see you, hope to see your children, hope to see your grandchildren, etc. You are all welcome. Thank you very much.